Okay guys, so we were discussing random forest in today's class. So basically one thing what I have discussed till now is nothing but we have a data set which look like features. Over we call it as column also, and rows we call it as instances, right? So what are rows? Like this, these are the rows, these are the features, right? So for the what decision tree actually do, the nutshell is कि it will take a feature, one of the feature, it will take any random feature, not random, there is a process called as entropy, then we have Guinea impurity, then we have information gain, right? So entropy, Guinea impurity, and information gain. Based on these three topics, I'll teach what these actually are. Based on these three topics, it selects a random feature, a feature, selects a feature, not random, a feature based on some property. So as soon as you this selects a feature, what it does, okay, it will check how it is dependent upon the target variable or any variable. Like what is your target? Let's say for heart patient, that person is heart patient, yes or no, right? So yes, yes, no, no, something y and y n. So what it do, it will make classes based on, it will make decisions based on what is the condition. For example, if yesterday also again nice same issue as expected. So nice. Okay, I'll change the software. I tried reinstalling and reinstalling it, but that didn't make a good difference. Okay, I am just sharing this screen. Is this visible, guys? Put a thumbs up if it is visible. Yes. So, acha, one more thing else. It will be not be shown to your people who's watching it. Not fine. And how to make this page landscape? Okay, no issues. I'll zoom it up. It will automatically become landscape. Okay. So let's say if we have a case, if we are talking about a person, right? A person. So yesterday I took an example from one of the known YouTuber, but right now I'll try to modify it. Nearly same thing. Or let's take the same thing. Okay. A person whose age is nothing but 14 years. Right. If any of you identify whom I'm talking about, just put a comment in the message box or in the whatever comment section we call in YouTube. So if the person age is 14, like the given condition, given is कि that person age is 14, and what we are talking about if condition was only to अच्छा black is also if age is less than equal to 15, then print the person is in school. The person is in school. Right. Again, after that, there we have elif condition. Elif age is greater than 15, and or you can directly put and also, and age is less than equal to 21. And in this case, just print person is in college. Right. Else, not like this. We don't have this for else. else print past college. Right. So we have three conditions. If age is less than equal to 15, then print the person is in school. If age is in between 15 and 21, the person is in college. Or and the last condition is कि either if both of them doesn't satisfy, then the third condition will be taken. Else print passed from college. Right. So how does this matter? Like what is we are doing over here? Okay, we are checking one condition. Like in the terms of decision tree, you can understand right now. The condition is कि age is greater than equal to 15. Right. So if the age is greater than 15, either chances are yes or no, right? Yes and no. If age is greater than 15, if age is greater than 15, what is the condition? Ki, what is the condition? If age is greater than 15 and less than 21. So there is a condition this, ki age is greater than 15 and, age is greater than 15 and age less than 21. Right. If no, age is not greater than 15, then person is in school. So I'll put school over here. Array, how to create a page? If this is the condition, yes means age is greater than 15, then what is the condition? If age is greater than 15 and age is less than 21. See, again two conditions are there. So if age is greater than 15, this is the condition, and no. If yes, if no, means this condition is satisfied. If this condition is satisfied, means this is and this is satisfied, then college. Else past college. Right. We are talking about this condition. If this condition satisfy, if yes, then he is in college. If no, then he passed out college. Right. Are you guys getting what I'm doing over here? Based on this. Everybody. Okay. Then here comes one more part. There is one famous data set. We call it as play tennis data set. Tennis data set. Alright. So what is the condition in this? Okay, I'll paste the the data set, how it looks like. You can also search on Safari or Chrome, whatever you have. Search play tennis data set. Yeah, I got the. Would not like to access it, don't. Is this visible, guys? This photo. Okay. I thought it is visible to a cheap, very bad quality. Just a second, I'll open the web page and I'll copy this image now. Yes. So what is the case over here? There is this is a data set of a player, a basic player, right? Where you can see something. Okay. These are the features, right? These all are features. So this is the target column. Okay, based on this, the main column which we want to figure out the importance of a data set, target column, on which we want to make the prediction. That is known as target column. Like heart patient, is it a heart patient or not? So this is the data set where that player, based on these days, like conditions, outlook, temperature, humidity, the outside environment, does he went to play tennis? No, yes, no, yes. So we can see that there is one condition, that is, this is binary. First thing, this is binary. binary classification. Right. In binary classification, what are we having? Yes and no. Right. So as we, if you like think of more, here we are taking one feature. Let's say Outlook, the first feature. Okay. To make the decision tree. Based on this, we will take the decision. Outlook. So what are the conditions we are having? That the three categories we are having: sunny, overcast, rainy, overcast, sunny, rainy, overcast, rainy. So again, we are having three classes in that. Okay. So we'll put three classes: first class, second class, and our famous third class, rainy. Current season, right? Rainy, summer, overcast, right? Yeah, overcast. So if you try to count ki how many times this condition went true, like when it was sunny and he went to play tennis, no. So we will count first no, and if the condition is sunny. So for all the sunny, I am using this blue pen. Okay, blue. आज ब्लू है पानी 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 और दिन भी सानी 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 सानी. Okay, so for the eraser part, I'll remove this overcast. I'll take some other color. Red for the rainy. Rainy, 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 rainy. One more color, green color for overcast. Okay, so now we can identify. Now in this we want to see two things. First, sunny is over here, two sunny are here, right? How many no are there? One, two, both are no. So we found till now two no's. Then here again sunny. So three no, one yes. Then one more yes. So three no, two yes, right? So we got three no's. Sorry, three yes, two no's. Right? Is it correct, guys? How many yes we have over here in the sunny? Check. One yes. Another.
मैंने उल्टा लिख दिया.
हाँ मैंने उल्टा लिख दिया.
Yes.
Yes. So that's what no. You should guys tell me कि भैया उल्टा लिख दिया. No. Sunny no. Then sunny. Okay, three no and two yes. Three no, two yes. Right? Is it clear now? And we'll just remove this. Now we'll talk about another columns. I'm giving you time. Slowly I'm going. I can go very fast also. But I'm going slowly such that how we are gonna do decision tree, how actually it is, you should be able to understand. So the point was, sorry, whenever a call came to my mobile, internet goes. So sorry guys. We will talk about overcast. Similarly, till now when I am finding about overcast, no, you guys find about rainy, right? How many rainy yes and no's are there? Okay. So overcast we have in green color. I'll take the green color now. Overcast yes, one yes, two yes, three yes, and four yes. Oh my God, all four are yes. So I'll put four yes. Some other color. 4 yes, 0 no. Right? Anybody counted for rainy one? How many yes and no's for rainy?
3 yes, 2 no.
3 yes.
2 no.
Is this correct, guys? Anybody one more confirmation I want? Yes, fine. Now as we got this much of the yes and no's conditions, okay, when Outlook is 2 times yes with summer, that person went, like 2 times he went when it was summer. For all the overcast day, see, whenever the Outlook was overcast, he went, definitely he went. And for the rainy, out of 5 times, he went 3 times only, right? Now what you can conclude this, the basic thing, first part, important guys, note it down. Whenever if 100% of the work is done, for example in overcast he went, zero knows, like the condition was 100% true, that that we count as leaf node, right? फिर like each time it has to be yes. If in case for example rest of the two cases, 3 yes 2 no's, 3 yes 2 no's and 2 yes 3 no's, what we'll do, we will do the further split, right? So again, yeah, split से याद है, this is leaf node and we call it as anybody pure split, pure split. And this again, if this is impure split, then this is impure split, impure split, this is also impure split. So what does a क्या कहते हैं random forest model do, not random forest, sorry, decision tree do, कि it create multiple decisions under a particular feature. Once it selected one feature, now for the summer one it will take temperature. Then once the summer one having temperature में क्या क्या था, hot, mild, cool. So again 3 categories, hot, mild and cool. Sorry, I'll go a little bit down. Hot, mild, cool, mild और जो भी कहते हैं, hot, mild, cool. Now the point is कि how many times he went for this, no no yes yes, both the condition. So until unless somewhere at the end you will get a leaf node, at end you will get a leaf node, you will get a leaf node, means you have to do till until unless you get a leaf node. Arey, get a leaf node. Is this clear guys? My note is getting messy but it's fine. Format, view, interface. One more thing, how I can change. Okay, in next class I'll try to figure it out how to change. Okay, leave it. Okay guys, so first thing is what is pure split, and we call it as leaf node. That node is called as leaf node. Pure split बोले तो either all are yes or all are no, like only one condition is true. Are you getting guys? Then many of you might encounter this question कि why outlook only bro, why you choose outlook first time, why you didn't choose something else? So to find out कि why to choose outlook only or which feature we should choose at the topmost, then where comes the concept of information gain. Information gain. What is information gain? It is nothing but it tells how the feature is selected, how and which feature will be selected, and which feature will be selected. Okay, as the main one, this is known as root node. Again, one more concept, the node which I am taking at the top is nothing but as root node. Write it down till here. If you are done with this, just raise your hand, then we'll go with the another topic. Everybody, I want everybody, if you are done with this notes, such that I'll go to the next point. See, I'll check this now, the ratio. Right now it's 6:16. Just a second now. 83%. 83. Nice. Just a second, guys. I'm just trading a model side by side. So just one line of code. I'll edit and I'll come. Huh. That model is selected. Base model क्या है? What is base? हाँ, done. Just let me start one of the epoch. Fine, guys. Let's continue. Hmm. Just as okay, guys. So here we concept the main question will come. Okay, one more topic is there before coming to the information game. There is one topic like what is pure split. Pure split we got कि either all yes or all no. But this is how we are doing, right? This is how we are doing, but how computer will be doing? Like computer should have something, some knowledge or some mathematical imputation, right? Mathematical imputation. So what is the mathematical imputation of selecting the pure split? Like when it come to know it is all pure split. So here comes the concept of entropy. So there is one word that is known as I'm trying to make it landscape, but yeah, rotate page. I got an option. Clockwise 90. Fine. Now this would be easy. So how pure split will be defined from the computer? So there comes the concept. There comes concept of entropy. Right. So we denote entropy as H of S. Right now, don't worry what is H of S. Just keep on going and you'll come to know. Right. We denote as minus of P positive log base 2 P positive minus P negative log base 2 of P negative. What is P negative and P positive? See, P negative, this is a binary class thing. Binary class. When your data set is binary thing, yes, no, maybe, might, the target column. At that time, you can use binary. Else, there is one more way, like C1, C2, C3. You can call it as C1, C2, C3 up to Cn. If you have more than 2, right? So in that case, it will look like H of S of C1 or comma C1 minus of C1 log C1 like log base 2 C1 minus C2 log base 2 C2 minus C3 multiply of log base 2 C3 till dash 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 Cn minus of Cn multiplied by log of 2 Cn. Right. So if you have binary class, right, like for example in the last example of the play tennis play tennis data set, we have binary class yes and no as the target variable. But if you in any feature, for example, if it is in any feature you are talking about, if you are having multiple classes, for example, Outlook was having 3, that was overcast, sunny and rainy. So at that time you won't use this one, you use this one, right? C1, C2, C3, C4, whatever. Is it clear, guys? And what is P negative, P positive? Nothing but probability of that thing. For yes, if it is negative, probability of no, probability of yes, probability of yes. C1 means again that column how many times that particular feature came. For example, Outlook came how many times? For example, I'm talking in the Outlook how many times Sunny came? So 1, 2, 3, 4, 5. 5 times Sunny came. So what is the probability of Sunny? 5 over how many total are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 5 on 14. So probability of Sunny is 5 on 14 for outlook. Same again, probability of overcast is 4 on 14, and 5 for 9, 9, 6, 15, 9, 5. 5 on 14 will again your probability of rainy, right? So if you are having multiple क्या कहते हैं category inside a particular feature, so at that time you can use C1, C2, C3 formula, else you can use binary one. Is it clear, guys? The notations of entropy. For example, C1, if you take C1 as Sunny 1, Sunny how many times we got? 5 on 14. So probability will be 5 on 14. We'll take an example. Right now we'll solve again. 5 on 14 minus, then minus of, again if you second category was rainy, so put the rainy, that is 4 by 14 dot 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 dot. Are you guys getting my concept? Is it clear? Put a thumbs up if it is clear. Am I audible, guys?
Yeah.
Is it clear, guys, for everybody? Is it clear? The concept is clear, or should I repeat it again? I'll give an example. At that time you'll understand, right? Till now, anything, any kind of doubt, guys? Arey. Huh. Any kind of doubt, anybody? Is it clear what I just right now taught you, guys? Is it clear? Raise your hand if it is clear. Raise your hand if it is clear. Four people still didn't raise their hand, means they have doubt. 3. Okay, no issues. Whenever you feel free at the end of the class also you can ask. Okay, let's take an example and we'll calculate. For basic example, yes and no example we'll take. Let's say we have a feature F1, right? And in that we have two category. Like Outlook have summer and that category, same we will take C1 category. And another category, C2 category. Like we have Outlook, no? In Outlook we are having sunny, rainy, one more was there, no? I forgot. Overcast. So in that, what is the condition? Ki like 6 yes and 3 no's are there. Like in that Outlook, how many times he went to the क्या कहते हैं playing tennis? Total yes and no. How many total yes and no's are there? So 1, 3, 4 to 6 to 8, 1, 9. 9 on 14. So in Outlook, 9 yes and 5 no's. Right. Similarly, we are having a hypothetical. Over here it is an example. Let's say we have a feature 1 which are 6 times yes and 3 times no. And in that, what is the condition like? For the C1, for all 3 yes and 3 no's, this was the C1 it went. For example, for the sunny also, how many sunny was there? 5 on 14, rainy 4 on 14. That probability was 5 on 14, right? So I made a mistake. We are not talking about probability, we are talking about yes and no. So for the summy, how many times it was yes? Somewhere we wrote, no? 2, 4, 3. Right, 2, 4, 3. Two, 4, 3. 0 4 2 5 times was this, तो ये 3 होगा, and this was also 5 times, so ये 2 होगा. So 2 yes, 3 no, 4 yes, 0 no, 3 yes, 2 no, right? This was the case. We'll do for this one Outlook only, right guys? Leave this feature. But we need, because I want to teach something, so let it be here only. Okay. So Outlook, we will calculate h of s, that is entropy. Entropy for which feature we are calculating? For Outlook we will calculate, right? But before Outlook, we'll go for entropy. We'll calculate for the summer. Entropy for the summer. So h of s, how we will write h of s for this? How many time was the positive one? Again, it has having positive, no? It changed the color here. हो गया. Positive one was 2 times. P negative was 3 times, right? On the scale of 5. On the scale of 5. What is positive means yes one. This is the positive. What is the no one? P negative. Similarly for this, what is P positive for it? P positive is nothing but 4y. 4 by 4. P negative is for 0 by 4. And for this, P positive is 3. P negative is 2. On 5. P is nothing but probability of having yes, that is positive, that is 2 by 5. Probability of having no, that is P negative, is 3 by 5. Any doubt till here guys? Because I'll just fastly calculate the h of s. For the summer I am talking, entropy of summer, h of s. How we can calculate? Just put the formula everybody knows, minus C1 multiplied by log of base 2 C1 minus C2 multiplied by log of base 2 C2 and C3, because we are having 2, no, so we won't use 2 1 because we are calculating for summer, right? So instead of C also you can put P, because again एक ही बात है, that is the extended formula. So minus P1 dot log 2 P1 minus P positive P negative dot log 2 P negative. So what is P positive guys? P positive is 2 by 5. So I'll replace 2 by 5 in the above formula, right? And this one also I need to remove, this one also. So what is P positive? Minus of 2 by 5. Why minus? Because there is a minus, this minus. Then log P2 P positive, again 2 by 5. This is 3 by 5. Negative is already there, so we don't need to add extra negative, and again 3 by 5. Firstly calculate the value, no? अबे आजा ना. Guys, calculate the value. Anybody? Shit. I want this answer. What is the value for this? Or should I calculate? Do you want me to calculate guys, or you can do it? Anybody give me the answer for this? I'll not do, you guys have to do. Anybody got the answer? Anybody? Anyone? Get the answer? I got the answer. Hey, you can take a screenshot and put in ChatGPT now. This is the one of the answer.
0.971.
0.975.
1.
Anybody else got this answer? Anybody else? Cross verification. Same. Okay. Is there anybody else calculating the answer? Raise your hand if you are calculating the answer. Nice. Too good. Aditya. Only one guy is calculating the answer. Okay guys, from the next quiz, whatever I will gonna take now, in that I'll put something like this. At that time you have to calculate. No matter what. Okay. Similarly, we got H of S, that entropy of the summary, क्या है ये S for summer is 0.971. Same calculate for the R, same calculate for the C. Right. So what does entropy tell us? Anybody? To check whether it is a pure split or not. Right. So over here we are getting 2 and 3. If you check for this one, check for the rainy one. That is very easy. What is the case? Minus 4 on 4, log 2, 4 on 4, minus 0 on 4, dot log 2, 4 on 4. Now if you do this, basic mathematics, 4 on 4, 1, 4 on 4, 1, 1, and 0 is something 0. So minus 1 dot log 1. What is log 1? 0. Right? Log 1 is 0, no? Hey, say yes or no?
Yes.
Are you guys understanding what I'm doing, or you are just क्या कहते हैं, somewhere else, physically sitting in front of camera, like front of laptop, mentally somewhere else, or both, physically and mentally somewhere else only, not in the class, just your laptop or mobile is attending the class, both. Okay, so what you got, log 1 is equal to 0. So log 1 0 means, okay, as you can see, for that rainy case, 4 yes was there, 0 no's are there. That means it is a leaf node. And what we got, entropy of this node as 0. Means ki whenever the entropy of a node is 0, then the node is pure split. Right? Is it clear? The one thing why we started doing entropy was to find pure split. Ki whether it is a pure split, how a computer will come to know, right? This we talked about, pure split computer. And how mathematically it will calculate. So this is how the mathematically it will calculate. Calculating the log, and once it is done, you will get a value. If it is a 0, then it is a pure split. If it is a very high number, then it, see, we guys got 0.971 over at the right corner also, and over here I am writing again 0.971. If it is become 1, let's say 3 on 3, 3 yes and 3 no's. So at that time, this is a impure split. proper impure split. Means there is still multiple decision trees are needed. You have to go for multiple decisions in that, right? If yours h of s, that is entropy is 0, means you don't have to dig now more into it, just stop it over there. That node stops there. Are you getting my point? if uh, if you are having something like this, and over here you got this node's entropy as 0, just stop. You don't need any more features to add over there. You don't need to compare it with anything else, right? So that's how computer will come to know using the entropy concept, that h of s concept. Okay, now I got the value 0, now I have to leave this node, go to the another node. If this also comes like 1, again check for another feature which correlates with this. Again, if this is still near to 0.5, again go check for another decision tree. Over here, one more tree. If it is not 0, if it is 0, if this becomes 0, leave that node, go to another node. Are you guys getting? And check for the decision. Make it pure node. Like all the rest of the nodes, we have to make it leaf node. The target is to make every node as leaf node. So what is the one of the main problem in the decision tree? As we do this part, no, going in depth and again tackling with another feature, checking yes and no, correlation with another feature. If yes, then again inside. Right. The point is this: ki once you go inside depth and depth by depth and depth, no, there is a very high chance of getting overfit. Very high chances of getting it overfit. Getting your model overfit. That's why you should, like if your features are too much, more than 5, 7, at that time you should try to avoid decision tree. If you use decision tree at that time also, nothing but your computational time will be more, nothing else. You'll get some result. That is not necessary to be proper result. That model might be overfit. Right. So one concept was entropy. Right. Another concept of checking for the this क्या कहते हैं pure split is known as your क्या कहते हैं मैं भूल गया Gini impurity. GINI, Gini impurity. Right. Before talking Gini impurity, I took one more example right over there of a feature F1 with the two children or two categories C1 and C2. For example, वो क्या कहते हैं आउटलुक वॉज देयर नो आउटलुक में 3 कैटेगरी था समर रेनी एंड ओवरकास्ट in this we'll take something just only 2 features instead of 3 we'll take 2 features, right? So and what is the condition? Why I'm taking this example? Because this leads to one more point, that is 6 yes and 3 no's, right? 6 yes 3 no's, and for that 3 yes is for this category and 3 no's, and 3 yes for this category and 0 no's for same, right? Means ki to the target variable, something is target variable, 6 times yes is depending upon from this, like overcast was 6 times yes, multiple time no's. Are you guys getting what I'm trying to say? See, come above, not this much above. See, outlook में भी अगर तुम उसको compare करोगे, if you try to compare this column with this column, how many yes or no are in the outlook one? See, these are the yes for the outlook also. For every one, this is the yes and no, right? For every column, this is the yes and no, right? Same thing I'm telling, if you take any feature, it will be depending upon the target variable, right? This is your target column, target variable, also target variable. So this is your target variable, and that what you have to compare with it. If 6 yes 3 no's, that what I'm talking about to the target column. Now once we are clear with this, 3 yes 3 no's, 3 yes 0 no. If you try to calculate entropy of h of s for your first one C1, what you will get? You will get minus 3 by 3 log base 2 3 by 3. For the no also you will calculate, sorry, not plus, negative only, negative 3 by 3. Why 3 by 3? Because P negative is 3 over here, and this is nothing but your total probability. I missed. 3 upon 6. 3 upon 6 log of 3 by 3. 3 by 6. I'm sorry. Then array 3 by 6 minus again how many again 3 by 6 only log 3 by 6. Calculate this one. यार इसका पेज तो इतनी जल्दी ख़त्म हो रहा है क्या बताऊँ मैं. Minus 3 by 6 log 3 by 6. If you calculate, that is nothing but 1 by 2. This is nothing but 1 by 2. This is 1 by 2. 1 by 2, 1 by 2. So what I am getting, half log base 2 half minus half log base 2 half. So this is minus of minus, same thing. If you take minus half common, you will get 2 plus over here, 2 plus add 2 log base 2, and this if you go in, that again you will get nothing but as 0.5. Check no, if this is the value 0.5. No, sorry, not 0.5, it will be 1. How much you are getting, guys, for this? The mine value is 1. Check yours value, how much you are getting. If you take minus half outside, it will become plus, and 2 plus are there. Log a plus b is equal to log a into log b. Then it's not that formula log a. Then, yeah, 1 will become. How much you are guys getting? Put right now I am seeing the screen. Earlier I was calculating. 1 only, right? So if it is coming like 1, means it is a impure split. Again I am telling you impure split. How impure split? What we talked about, this 3-1. See, this is 3y 3n c1. Means 3 yes and 3 no's. Means if you are getting one, impure split, means you have to correlate with another feature. Now earlier it was something like outlook, then in that summer was there. Now you should go with the, if you are talking about summer over here, go with the wind. Make a correlation with the wind. If it is yes and no, summer and windy, yes, summer and not windy, no. Then again you have to do correlation again. Are you guys getting? How many of you got the concept? Raise your hand. Raise your hand, not thumbs up, raise your hand. How many of you got the concept? This is one of the important topic which will be asked in your interview if you are appearing for the machine learning developer. One of the important question. What is entropy? How we will decide that the first node will be the root, that root node will be what, which feature will be selected. And how many of you didn't get the topic? Raise your hand. If you didn't get the topic, raise your hand. Okay, 1. Anybody else who didn't get the topic? Where are you facing issues, Ivans? Or we can have a talk at the end. So if you have any doubt, you can clarify over there. Is it fine? That I didn't complete it till now. Don't worry about that. Apart from that, this Guinea split. Okay. Rest is fine. Okay, this is entropy. This HS of now is entropy. Now we will do one more thing. We'll talk about C2 also. Why I'm focusing more on entropy? Because I'm gonna draw a graph and correlation between entropy and your this Guinea index, Guinea impurity. Guinea impurity mathematical formula I haven't taught till now. That is very easy. And once it is done, your this decision tree concept will be completed. And small more concept, that is your information gain. Like it will take time. I think so. Yes, it will take time. Okay. Hang on, guys. Then no issues. We have one more hour. H of S of C2. means 3 years, let's say how much 3 years 0 knows. I'm talking about this. 3 years 0 knows. So we are having 3 yes and zeros no. Means P positive is nothing but 3 by 3 minus log base 2 3 by 3 minus 0 by 3 log base 2 0 by 3. Right, so this is 0 basically, and 3 by 3 is nothing but 1, 3 by 3 is nothing but 1. So minus of 1 log 2 1, that is nothing but your 0. So how much you got? 0. So as we can see, H of S, entropy of C2, how much we got? We got 0. That means it is a pure split. Right? So this is how you can decide whether a split is a pure split or an impure split. Any doubt till here, guys? So you can conclude one thing from this, like add, not conclude. Entropy ranges from 0 to 1. Right? Let's do one thing. We'll plot a graph, a basic graph. So for that So let's talk about a graph, basic graph. Over here, what is the concept? K will mark a point. Here I'll put P positive, P negative. Oh my god. Require hold to snap. Okay, let's try. Acha, okay. P positive and P negative in this way, and here we will put H of S. So we saw that if you talk about the last example or before that example, same thing. Over here, what was P positive? P positive was 3 by 3. That means 1. And what is P negative? P negative was 0. Right? 0 by 3. That is nothing but your 0. Right? Right, guys? Say yes or no. Say yes or no. This is thumbs up. Okay. You guys know. So what we can see, P positive was 1. I'll put it in a bracket. P positive was 1 and P negative was 0. In that case, we are having pure split as 0. Right. Okay. Again, we'll go little bit above. What we'll see over here, Guinea impurity, leave it right now, Guinea impurity. So what was H of C1? We calculated as 1, right? So H of C1 was 1 at what time? At what time? When we are having P positive equal to 1 by 2, that is 0.5. And what was we are having P of negative? Also as 0.5. Right. Okay, we'll go one more example like we have taken for this, no? This case also. Apna weather wala, outlook wala. So H of S was 0 when H of S was 0, when 4 yes and zeros no's were there. Right. So P positive was 1 by 1, that is 4 by 4, and P negative was 0, means 0 by 4. Right. Then H of S was 0. Means either P positive is 1 and P negative is 0, we are having H of S 0. So means P positive as 1, this is 0, this is 1. P positive or P negative, whenever we are having 0. H of S is 0. So same 0 we will take. Right. Then there have a concept of 0.5 also and 0.1 also. When we are having 0.5, H of S is 0.5. When we got H of S is 0.5. Okay, that will come in Guinea impurity, right? So leave it that. Okay. And when we are having H of S, P positive and P negative at 0.5, where we are having over here. See, P positive and P negative are having 0.5. At that time, H of S is 1. H of S is 1. So at this point, H of S is 1. Right. I'll take this one, I'll mark it. And nice. Over here. And if I do over here also, it will go, right? This we got, right? Is it clear how I plotted these 3 points? Any doubt? Because we saw that ki P positive and P negative, when P positive was 1 and P negative was 0, at that time we were having value as H of S as 0. That's what. And again we are having P positive as 0.5 and P negative as 0.5. At that time we are having H of S value as 1. Right. Where I got this values from? Just over here. We'll talk P positive equal to 1. See over here, P positive equal to 1, P negative equal to 0. How much I got? H of S is 0. So H of S is 0. Then P positive is 0.5, P negative is 0.5. How much I got? H of S 1. So I got H of S as 1. I'll just I'll just join the lines. So I'll get something like this curve, right? So this is nothing but your entropy curve. Arey chacha. Entropy curve. Any doubt till over here? Over here you can give the name as entropy graph. Right. Today's session might go to 7 or 7:30, so no worries. Any doubt till here? Anybody needs a tea break? Guys, any doubt till here? Is it clear? Put a thumbs up. Fine. Okay. Now we will talk about Guinea impurity. Should I proceed with Guinea impurity, or anybody have any kind of doubt you want to ask? Or you want to tell me I have a doubt over here? Should I proceed, guys? Okay. Okay, we'll now talk about Guinea impurity. Guinea impurity. See, one of the way to find H of S is using entropy. H of S बोल रहा हूँ. Pure split or impure split. Pure split or impure split is entropy. Another way is this way, right? And when to use which one? Like when you will be passing your computer to tell when to use entropy, when to use Guinea impurity, we'll talk about that also. But first we'll complete this. Right. So Guinea impurity, the formula of Guinea impurity is nothing but 1 minus summation of I is equal to 1 till n. N means for all category what we have for that particular, and P. Right, P square, that is positive P plus P negative. If you classify this formula, like if you put more, expand the formula, it will look like this one. P positive square minus P negative square. Right. And for I is equal to 1 means for every I is equal to 1 till n number of category what we have. Like for example, if you are talking about 2 categories, so only we will talking about this one only. If it is having 3, so for 3 we will talk yes, no, maybe, like sunny, cloudy, rainy, whatever we have, right? So if you put, let's say, if we have a condition node with 3 yes and 3 no's, okay, that condition is 3 yes and 3 no's. So if you put 3 yes, 3 no's, what you will get? 3 by 6 positive case square minus 3 by 6 negative case, right? So that is nothing but half 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 half. 1 minus half ka square is 1 by 4 minus 1 by 4, that is 2 by 4. 2 by 4 is nothing but 1 by 2, that is nothing but your 1 minus 1 by 2 is 1 by 2. You guys got getting my point? That is nothing but 0.5. So what we can understand ki if p positive and p negative are equal and the maximum 0.5, like p is equal to 0.5, p positive also equal to 0.5 and p negative also 0.5, we have Gini index is equal to 0.5, right? So at a middle point we got 0.5 and 0.5. So in this only I'll draw that graph. Or you want another graph, I can draw in that. Or you want in this? Put a thumbs up if you want in this. Put a thumbs down if you want in another. क्या मिलता है तुम लोगों को मुझसे काम करा के? What do you guys get after this, giving me this much of work? Okay, see. If you talk about Gini, I'll again put P positive. Arey chacha. P positive, P negative. See, this is a Bhojpuri tune. Arey chacha. Okay. How many of you know Bhojpuri? Raise your hand if you know Bhojpuri, Bihari language. Is zero. Zero. Raise your hand, guys, if you know Bhojpuri. The sweetest language is Bhojpuri. Right. Bengali is one of the sweetest again. A lot of languages are sweet. Like, if they abuse you also, it will feel like nothing. They're doing tarif only, like praising only. Okay. So what we saw at 0.5 of P positive and P negative, it was 0.5. So we draw a point over here. Now we'll check for P positive at 0 and P positive at P negative at anything. We'll check. Okay. So let's say one more example. Over here only we'll take a node. Again, in that node we'll put 3 yes and 0's no. So if you calculate for this 0 no, again 0 no, it will become minus 1 minus P positive ka square, that is 3 by 3 ka square, minus 0 by 3 square, and I think it needs zoom a little bit. No, it's so that will be 1 minus 3 by 3 square is nothing but 1 square, 1 minus 1 square minus 0 square, that is nothing but 1 minus 1, that is 0, right? So what we saw that if P of positive is 1, P of if P of negative is 0 and P of positive is 1, we are having entropy, not entropy, Gini index, Gi, Gini impurity, not index, as what is this? 0. So P negative and P positive at 0 and 1, if this is 1, P positive 1 and P negative 0, we are having Gini index is 0. Okay, so this will be on the over here, point over here. Now if you join it, you'll get something like this, right? This is your Gini index graph. Not index, Gini impurity, guys. Sorry. Impurity. Gini index, or again like Gini impurity. Is it clear? And that similar was for this, no? Entropy, it was going to 1 somewhere over here. If it is 1, it was going something 1 over here for what? Entropy. Right? If it is 1. But Gini impurity, it is going maximum. So what you can write, okay, what is the range of Gini impurity? Is nothing but 0 to 0.5. GI ranges from, Gini impurity ranges from 0 to 0.5. See guys, if you are gonna attend AI works after this, I'll kill you, okay? Over there, this will be like new to all, and very fast I'll cover. Like within a day, I'll cover 2-3 algorithms. So it's fine. That will be more interesting because at that time I have slides, I have emojis, but it's fine. We can still enjoy. But when it is strictly something important, you should pay attention. Huge data set. The point is huge data set. If you are having a huge data set, in that case you should not go for entropy. Reason being, it is using logarithmic function, right? So if you are using logarithmic function and you are again you have to find log, that increases your time. Instead of that, go for Gini index. If you are having huge index, go for Gini impurity, not index, Gini impurity. Are you getting my point? Again, if you want to say second option to make it more better, at that time you can use both, like one after another. If you want to use, you can use. Is it clear, guys? Okay, how to check whether a feature is pure split or impure split, and when to decide and when to stop the tree. Right now, what we have discussed is to stop the tree branches. When the branch has to stop, it not has to go infinity, right? It won't have to go infinity. So what is the endpoint? To find that endpoint, we are calculating h of s, or Gini impurity. Once the Gini impurity we found, okay, it is 0 or 1, in that case, we'll stop it over there. Are you guys getting? Any doubt till here? So for the Gini index, what is pure and impure? So if you are having this as, if you are getting 0, then again, this is your pure split. If you are getting something else value, that is your impure split. Same for that entropy also, right? If you are getting 0, then it is your pure split. If you are getting 1, it is your impure split. So this is the way, when your tree had to stop thinking, this tree had to stop making relation. This is what is decided by this entropy and Gini impurity, right? Now a question arises ki, brother, which feature has to be selected when? Like, okay, I got ki this is how, till when we have to go, but with which path we have to go to find the particular path? Like, we have to choose weather first, then we have to check for the wind, or then we have to check for the humidity, or first we have to start with humidity, then we have to check for weather, or simultaneously I have to check for wind speed also, then the outlook also. The point is this, the main question arises ki which path should I take? Which path? Not path, which feature should I select? Which feature should I select, or should I start with? See, if you do without this, you have to do permutation and combination for each and every node, right? Each and every path you have to find. But what is the most optimal node I should start with, and what is the next optimal node I should go with, and again and again and again. Are you guys getting what you have learned till now and what you are gonna learn now? till now you have learned which path, like in depth, how many layers I have to go, how many in-depth layer. See, this is known as levels. These are known as levels. So how many levels do I have to go at down? That is steps you can put. How many steps I have to go? That is find by this one, h of s and Gini impurity. And when to stop? When to stop is find by this. See, multiple lines I'm talking about the same concept. When to stop, how many levels we have to go, till where we have to go, till where. Now the concept is ki which path you have to choose. Which path? For example, you decided to go from Bangalore to Bangkok. Okay, your favorite dream place. Alright, or Thailand or somewhere. Right. So at time you are thinking ki when to go. That is your Gini index or entropy. But which path to take means directly you want to go to Thailand, or you want to stay, or you want to lay over in Bangkok, then you will go to Thailand or something like that. So that is your path selection. Are you guys getting? When to go means when you are leaving from your home and you want to like not from home, you are leaving from college and you are thinking like, yeah, I'll go to my friend's house. So when you have to go back to your home, that is your Gini impurity and entropy. But where to go, what path I will take, that will be the optimal path. Like from where, what are my stops, where I will stop, and this is the path I will follow. That is your this one feature selection. Yes, feature selection, yeah, path selection, or which path, or you call it as information gain, right? Which feature to select. You guys got my point? Like you guys decided to party at night 11 p.m. right? But you guys didn't decide whose home you will choose. Like that's what you have to decide using information gain. We call it as information gain. Information gain. So information gain, a small problem statement I'm telling. Let's say this is feature 1, this is your another category, and again you selected another feature. So this is the feature you are taking. You should start with F2. Let's say if you have F1, F2, F3, F4, F5, F6, blah blah blah, F of n features. So which feature you will start your root node? That to decide that thing, we use information gain. So what is the concept of this? Nothing but we denote it as gain. We pass S and the feature which you are talking about. We have to calculate the gain of each feature, right? So how we find? So before starting, we'll take an example. For example, we have a node, right? For with feature F1 name, let's say 9 yes and 5 no's. In that 2 categories, C1 and C2, right? For the C1, 6 yes and 2 no's, and for this 3 yes, how many no's are there? 5 no, 3 no's. See, always you have this should be the case key. Some of these should match with this. Reason being, because how you are reaching feature 1, that is the summation of both. If you can understand, or if you want me to go in depth, I'm going like upper level, not going in depth. If you want me to go in depth, I'll go in depth. Are you guys understanding? Is it getting bored? Somebody put thumbs up when I asked, is it getting bored? Nice. How many of you got the concept? Raise your hand. Because if I skip this part now, at that time, at the time of random forest, I can't help you. So how many of you got the concept? Raise your hand. Only 11 guys. 12. Okay, fine. Now we can go for it. Okay. So what is the formula for the gain, or how we'll calculate? Let's say this is the distribution. So the gain formula looks like gain S of F1 selected column, yes, h of s, h of s, h of s minus summation of v goes to values, and for what? For all s of v divided by s mod of s, then I forgot, so multiplied by h of s, h of s is, I think so this is the formula. Okay, once we'll calculate it, we'll get to know. Okay guys, so okay, over here I'll do, see what is f1, whom we want to make the root node, whom we are talking about, रूट नोड कि क्या हमें इसको रूट नोड बनाना चाहिए, डज दिस फीचर डिजर्व्स टू बी बिकम अ रूट नोड, देन h of s is nothing but entropy of that node, what we just calculated above, entropy of that root node, right? This is your sample category, and this is your sample of root node, then again entropy of that sample category, right? We'll do one thing, what was the problem I gave, 9y 5n, so I'll put it over here, f1 with 9 yes, 5 no's, c2 c1, and this was with 6 3 3 and 3, right? 3 and 3 yes, 3 yes 3 no, 6y 2 no, right? Yeah, now we'll calculate the gain of this root node, s of 1 f of 1, right? So what are the values you can give? First we have to find this h of s, we'll find h of s, so I'll write the formula once again, h of s minus summation of v belongs to values, s of v divided by s modulus, as it is not gonna be the negative but still, and this was the sample, no right to mention, then h of s is free. Okay, so we'll calculate h of s. What is h of s? Minus of p log base 2 p positive, if we are talking about p positive, minus p negative multiplied by log of 2 base 2 p negative. So how many p positives are there and p negative? We are talking about f1, right? So we'll put the value of f1. I'm not talking about c1. Again I'm giving f1, I have written f1, so I'll talk about f1. So what is, how many positive are there? 9. 9 out of what? 9 out of 9 5 is 14, multiplied by log 2 p positive, again 9 by 14. How 14? This probability of getting yes and probability of getting no. Probability of getting y is 9 by 14. How? 9 plus 5 is 14. Total outcome upon favorable outcome, that is probability of particular outcome, right? Favorable outcome upon total outcome, minus over here one more minus, then 5 upon 14 into log 2 5 upon 14. If you calculate this, it will come roughly 0.94. Roughly I'm talking about, roughly at 0.94, right? So what's the point now? The point is okay, we got h of s, so we will put the value. But if you want to talk about h of sv, how you will find h of sv? We are talking about particular, this one c1, like values. Oh. For that you have to find h of s1 as well as hs of entropy of c1 as well as entropy of c2. So how we will find? Just we'll use the basic formula. Why we want to find c1 and c2? Because we are having summation over here. Right, for v for values, how many values we are having? We are having two values, c1 and c2. So for that we have to use this one. And what is the values for this? I'll just right now, you will come and you will understand. Right, so we'll find h of sv first. So for h of sv, and over here v is nothing but our h of s of c1. So we'll find c1, that is nothing but 6 to 8, that is 6 by 8, 6 by 8, negative ka. Just a second please. There was an issue while writing, now it might not be. Right, put log, and in that 6 by 8 minus ka 6 by 8 is there, and what is next? 2 by 8, that is negative ka, dot log 2 by 8. If you do simplification, minus 6 by 8 is nothing but your 3 by 4 minus 3 by 4 log of base 2, 3 by 4 minus 2 by 8 into log of base 2, that is 2 by 8 is 1 by 4, log of 1 by 4. If you solve this value will come nearby 0.8. Right. Okay, yes. And if you try to calculate for h of s of c2, what values you will get? H c2 is 3 by 6. Again, this is, if you see this, 3 and 3, 3 by 6 and 3 by 6 is nothing but your impure split, proper impure split, right? So what is the value of h of s when it is proper impure split? Anybody? Is 1, yes, 1. If it is proper impure split, no, over there, over at the top I told you guys, if it is proper impure split, over here also you can get, if it is proper impure split, that means it is the 1, that means proper impure split. See, impure split, if you get 1, that means impure split. So h of s is equal to 1 because it is impure split. Just a second, I'm just checking something else also. Wow, very bad. Very bad. How much? What is this? 62%. Okay. See, right at the back end, this is also running. My system is running now, so it will take like it is taking resources. Sometimes I feel laggy. No need of this now. Okay. So what is gain split? Again, we'll write the formula. Gain split ka S1 S comma F1 for the sample 0.94 we got for this 0.94. Over here we'll just put the values of what we got. So over here it is 8 in this, 8 by 14 in this case. How 8 by 14? So how many samples are there in this C1 category? 8 samples are there, no? 6 was Y and 2, no, total 8. Out of how many? 9 plus 5, that is 14. That is sample of the feature. This S is nothing but, over here I gave you, na, sample of the root node. What is the sample of the root node? Sample of the root node is nothing but total 9 plus 5 is 14. That is sample of the root node. Root node का sample कितना हुआ? 14 हुआ. This value become 4. And V is nothing but we are talking about each and each category. So C1, how many values are getting? 6 and 2. 8 values are passing into C1 category. So 8 by 14 for the C1. Right. And for this, how many values are passing into this? 6 out of 14. So how many values? 6 by 14 for C2. Are you guys getting how to calculate sample value of that particular node upon the root node? Sample value of that node, how many nodes values are getting? 2 values. Let it be yes and no. Like total number of values present in that node, 8. Over on the C2 node, how many values are present? 6 nodes. Okay. How many total nodes are present at the root node? Is 9 plus 5, 14. So the particular given feature, not feature, category node divided by number of samples of the root node. For the number of samples present into the another node, another child node or whatever you can say, category node, divided by the sample of root node. Is it clear, guys, how I got 8 by 14 and 6 by 14? Put a thumbs up if it is clear. And raise your hand if it is not clear. Thumbs up is if it is clear, raise your hand it is not clear. Okay, just put this value over here. That is nothing but 8 by 14 minus of this multiplied by how much I got in C1. See, for the C1, what is the formula telling? Multiply S of V, particular that category we are talking, and उसका H of entropy value, उस category का entropy value. तो entropy, उस category का entropy value, how much we got for the entropy value of this category? 0.81 multiplied by 0.81. Okay, plus because summation was there. What is the this sample value of this one? How much we got? 6 by 14, right? Multiplied by what is the entropy we got? 1, because it was a impure split. So this is the case. Are you guys clear why I have written this way? How I came to write this part? So if you calculate, see, from my notes the value is around 0.049. You can check it. Okay. If it is wrong, you can replace. Now we got the importance of that particular feature as 0.049 for that particular feature. Let's say there are 5 features in your data set, right? So one feature was having gain of, see, similarly we found for feature 1, no? Find for gain of feature 2. Gain of feature 2. Similarly for gain of feature 3. Feature 3. Gain of feature 4. Gain of feature 5. Let's say 5 features are there. If all of them have different value, let's say for this one I'll erase. If feature 2 was having 0.049, no, 41, feature 3 is having 0.072, 0.091, 0.001. So the most highest value you will pick. The most highest value is of the feature 4. You will make this as the root node. Right? Why? This is the reason. Because you calculated gain. Okay, which is the most important feature among rest of the features. Once you selected the root node, now go select the, do this step level wise. We do find the entropy. What we have to do, is it a pure split? If it is an impure split, find the entropy for that feature. How many classes are there? How many categories are there? Once you calculate that, again check for the, if your entropy is 1, definitely you have to now split it into more classes, right? So that's the point, until unless it becomes 0. So which features to select? Again use gain. Whatever is the next, put the value over here. Is it clear, guys? Is this topic clear? Seriously, how many of you got the point? Like, got the concept? Raise your hand if you got the concept. Till then I'll open the meeting. only 6 people out of 15 minus 2 13 out of 13 6 people got the concept. Hey, only 6 people literally, or my internet is slow? Okay, how many of you didn't got the concept? Raise your hand. How many of you didn't got the concept? Acha, how many of you have doubt in this concept? Raise your hand. Okay, again same question. How many of you got the concept? Raise your hand. Eight on 15. 9 on 15. Who are those 3%? 15, including me, so 3, 3, okay. 12. 2% still. Who are those 2%? Acha, how many of you are there in the meeting? If your hand is raised, leave it raised, else raise it. How many of you are there in the meeting, attending classes? Now I got the concept. No. Why there is 2 people left? Okay, guys. This was your decision tree. That's it. Finish. You can take 2 minutes of break, then I'll continue. 18:16 is there, no? 18:18 you have break. 18:20, let's a 5-minute break. Go, freshen up. Whatever you want to eat, bring it. Because we'll go for the random forest now. If anybody have doubt, you can ask. The main topic is done, like the basic concept, how this work. Now more things are there, like use cases, when to use, right? So, but some definitions are also there. If you want, I can put it over here. Advantages, disadvantages. Okay, you can take a break for 3 minutes more, then we will continue. I am back, guys. So let's start with the class. Should I continue? Put a thumbs up. If you are back to your screen, just put your thumbs up so that I can come to know. Okay, yeah, you guys are here only. Raise your hand. No, no, thumbs up can't define. Raise your hand if you are back. Eight out of 12. Any doubt? You guys have any doubt? Any doubt? Okay, let's start with the class now. Hmm, lower hand. कैसे करते हैं? On the go. No, 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 not on the go. So presentation. Yes, from here I can look. Okay. The next topic is random forest classifier. Right, not classifier, random forest. And before that, some of the basic thing you can write in this. We'll continue writing in this. Some basic stuffs. Advantages, when to use, when not to use. अरे खुल जा सिम सिम. Okay. So what we till now what we came across of decision tree, that it has to make decision at every level, right? So what are the key terms or basic terms included in this? Pehla, decision tree itself. So you can write in decision tree a tree like model, used for classification as well as for regression regression tasks, right? Then we come for the most important part, that is node. What is a node? So node is nothing but it representation of it is a representation of a feature or column or attribute, right? Then third is edge, or we can call it as a branch also, like tree has branch, so similarly with branch. So what is edge or branch? Edge and branch, outcome of a test condition, outcome of a test condition leads to next node or feature. You can put leaf also, right? Remove feature, no? Feature is not a good answer over here. Node or leaf. So बहुत ज़्यादा ले आ रही है।
अरे ढाई बनाया था उसमें से कितना?
तुम ढाई का मुझे हाफ भी नहीं दिया है, ठीक है? ढाई में जो 2 के बाद हाफ लगता है ना, वो है ये हाफ।
ढाई नहीं 1.5.
वो 1.5 होता है।
How are you doing?
हाँ ठीक है, चलो। तो मतलब 1 तुम खाएगा, हाफ हम खाएंगे। अपनी साइज देख, मेरी साइज देख। ओके गाइस, ब्रदर थिंग। What I can tell, he's in class 10th right now, one of my maternal uncles, and he cooked Maggie 1.5 packet, right? He gave me half packet to me, who is much bulkier than him, and he took 1 packet for himself. See the discrepancy, guys. This is how I can survive in this क्या कहते हैं, selfish world. That's why you should not trust your brothers. Chhi. Actually, I am hurt now. Okay, guys, no issues. ये तो होता रहता है। कोई बात नहीं। हाँ, अच्छा, in DSA there is a class going on DSA. I'll tell it later at the end of the class. Just remind me to tell. Okay, so outcome of a test condition leads to next node or leaf, nothing but the branch. This is the branch. Test condition बोले तो yes, true, false, yes, no, whatever the class was there, no, yes, no, that is we are talking about a test condition, right? So that is nothing but a way of saying. It was in my notes, so I just am writing that. So okay, then let's continue with the next part. That is your fourth part. That is your leaf. बोले तो terminal node. Terminal node. So what is terminal node? Where we know that कि that is having the pure क्या कहते हैं उसको? I forgot the term. Oh my god. Leave. I'll just copy paste the notes thing. In my notes it लिखे endpoint representing a class like or value. Okay, then we'll create one more page. Then fifth topic, nothing but your root node. What is root node? Nothing but your topmost node where splitting starts. Right. Then what is splitting? Process of dividing a node into 2 or more subnodes. Process of dividing a node into two or more subnodes. Guys, on this application, no, my handwriting is little bit better, no? Do you agree? Yes. Means that was fault. Aniket Kumar, no, chi, bro, you broke my heart. 2 or more subnodes, okay. And I'm getting bored, that's why I'm making very faltu jokes, very bad jokes, but it's fine. Guinea impurity or entropy. Nothing but metrics to measure the quality of a split. Metrics to measure quality of a split. Quality of a split. Right. This is the seventh point. Now the last one is pruning. Pruning. See, don't worry about this pruning one. I'll teach later. Removing branches. To prevent overfitting. Prevent overfitting. Okay. So this is the basic thing, and we are going to talk about the use cases. So the next topic we can put is use cases. So what are use cases? You can use for medical diagnosis, in predicting diseases, then customer segmentation, then fraud detection. Okay, yes, if fraud detection is there, you can put this also. Credit scoring. Now the point comes when to use this algorithm. When to use. See, it is used for both classification and regression, and we just discussed about classification one. Regression one is not right now needed, but it is same as of mean square error. We find mean square error in linear regression. Same thing you have to find for each and every node, each and every value, like this categories and values, whatever we have, might be 3, might be 4 different values. So once you find this mean average, mean square error, so once you get these values, on the behalf of that you have to calculate the this precedence of the feature, which node has to be selected and which not, and to find ki that's it. Basic thing is we use MSE over there also in regression, right? So if needed, if we worked on something regression part, regression data set, at that time I'll explain or leave it, because I don't think this is needed right now. First understand classification one, get the insights of regression one, and like what is the end goal of this course I'm thinking now. I'll tell you in shortly the end goal of this course. First, we're done with the EDA part, the most important part. Then we're done with the feature engineering part. Then we will be doing 5 or 6 supervised learning algorithms. Then 2, 3 unsupervised learning algorithms. Right. After that, the key like what I'm targeting by the end of like 10 or 25. My target is 25, but 10 big projects and 15 small projects. And what we have done till now, nearly we are completing this today. So this part is left, right? So I'll cover 2 unsupervised को मैं अभी ये पढ़ रहा था, useless 2 to 3 unsupervised learning algorithms. Okay, we'll be covering, and 10 to 25 big to small projects. Right, this is the end goal of this course. Is it worth it of what you have paid to for 49 rupees, guys? Yes, 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 yes. See, one more thing, seriously, again, like multiple time, I also want to be on time. And last week, some of days were off. Some of day I came late around 7. I keep on postponed it from 4 to 5 to 7 to 9. Then at the end, I cancelled the class. Sorry for that. Sorry. Reason being, why, you should also know the reason. No? See, some work was going on my home. Frankly, electricity work, whole connection of the electricity of a floor. So I was the only person who was taking the in charge. Again, some of days, somebody got injured. Day before yesterday, or 2 days back, my maternal grandmother got some like high BP and something. Then I have to went to hospital. Then some days I had to see every day at 4 o'clock. Earlier the class was 4 o'clock, right? So we shifted. Now it is 4:30 because at 4 o'clock I have to pick my mother from school. Right? She's a teacher, so at 4 o'clock she leaves, so I have to pick up. That's why someday it is late 4:35. All right. Someday I have to leave somewhere else. I have to go get some medicines, get some equipment required by that labor. So multiple things were there at the same time, and multiple like I frankly tell you guys, some work was there related to research and all. Due to this much of busy thing, and after you have to like you guys are there also, then more 2 3 classes are going on. I was busy little bit, but right now I'm free, solpa solpa. So that's why I'm telling sorry. Multiple reasons were there. Whenever I was texting, no, I was feeling bad. So I'll try to not have like not to repeat this problem again and again. So again, last time sorry, and I speak sorry very rarely. Okay, if I'm saying, just accept it. Okay, let's continue the class. So this is the end goal of our course, and when to use. The main question comes when to use this algorithm. The first part, when your interpretability of your data is required, like you want to know ki which data is which column is performing more, which is the more important column, or interpretability. The best word is this only, interpretability. Ability, yeah, interpretable. Ki when you want to understand, for example, we found h of s, entropy, why this is important, right? So when you want to know why, at that time, good to use decision tree, right? So if you are having like 7 8 features, and you want to know which are the key important features, deciding features, you can use this one, right? So the first, I just erased. The first case is when interpretability is required. Just write when interpretability is required. That is Q. Again, my G and my Q looks same, guys. So adjust it as per word. Okay. It is not registered, it is required. If you ask me to write registered, I'll write register as a. If you if you tell me to write required, I'll write required. So you have to find which is Q, which is G. All right. So, yeah, after this, after the end, okay. After end only, like after the completion of this, before giving the certificate, everybody have to fill that feedback form. Right. And if you have not given feedback to our website, kindly go visit over there, put a feedback. Okay. Because right now we don't have time to scale it up, but when we are gonna scale it up, like next AI Works event will be with HCF, in collaboration with HCF, right? So that's why We want it to be make it more public. And one more announcement is there. I'll make it at the end because that is the one of the thing I promised that I have to bring to the society. Okay, when interpretability is required, another part is, just a second, I'll open my notes. When you need a fast baseline model, when you need a fast baseline model. Okay, for what? Baseline model. Baseline model क्या लिखा है? For classification and regression. Classification and regression. Okay, something it means I don't know. Let's go to the next part. When you need a fast baseline model. Baseline model बोलो. Just a second, no? I'll search, I'll tell you what is baseline. A simple model method for the reference point to evaluate performance of more complex models. Okay. Put it over here. Baseline model in machine learning is a simple model or method used as a reference point to evaluate the performance of more complex models. Right. Now it is here. Okay. Next point is data contains both numerical and categorical features. Yeah, correct. When data contains your data set, not data set contains both numerical as well as categorical features. So we know decision tree works for both classification and regression model. So definitely if you are having numerical features, so at that time also you can use. If you are having categorical feature also, at that time also you can use. Right, so two thing is there, one it is classification and regression, and one again decision tree. If your features are numerical and categorical, at that time also it is used. Right, so this is not class set, this is data set. Another next point, advantages. Leave advantages. I'll just speak, right? If you want to write, you can write, and recorded video will have. Advantages are easy to understand and interpret, correct. Requires little data pre-processing, no normalization and scaling. Yeah. In advantages, you can write this one. Good point. No normalization required, or no scaling for decision tree. Right. Works with both classification and regression, what we discussed over here. Classification and regression works with both. Handle both numerical and categorical data over here. Both numerical and categorical data. Okay, disadvantage, this is important point, you should know. Disadvantages. First disadvantage is it is too much prone to overfitting. We already discussed how. It is unstable. When small variations in data are present, or we can redefine variations in the data can lead to different trees. See, for example, if we are having this node in pure split, we have a leaf node. In that 4 yes and 0 no, right? If in case you inserted one row, in your data set, you have this much of your data set, this is your row. You inserted one row which is having one no for this. At that time, your whole tree will be hampered. Right. So unstable because small variations in the data can lead to different tree. Totally different tree. Everything will be different. Right. Again, we discussed about prone to overfitting. How? For example, this was having, let's say you are having 4 features, right? 4 yes, 0 no, 0 yes, 3 no's, 3 yes, 3 no's, 2 yes, 5 no's, and 3 no's over here, right? And something something. You can see one thing over here, guys. 4 yes and 0 no, 0 yes, 3 no's. Whenever you are having this, like, so what decision tree will think, no, okay, it has to be this way only, but it is not the condition in the real world. It is not always the condition that it will be yes, and it is not the condition that it will be no. So one a single, what we discussed, no, okay, one insertion of data can lead to different thing. Similarly, but your model will try to adapt this pattern. Means it is not learn the result, like what is the outcome, yes. So every time something will come, it is yes, no, zeros, no. Every time, like a person can die if it is less than 60, chances are less. Natural death less than 60, less than 20 le lo, less than 20 and 21. Natural death, let's say no, the reality is no, let's say reality is no. So reality is no. So all of this will be 4 no's and zeros yes. Let's say 4 no's and zeros yes. 4 no's and 4 no's, zeros yes. Now what it will do, it will learn the pattern. It will learn the pattern. And if you added one thing, it will just remember. It is not learning, sorry, it is remembering. Like क्या कहते हैं ना, रटना. We try to mug it up. It will mug it up. It will not learn. So whenever you add one thing, no, so this will be learned to overfit. Or whenever you try to put it into the real world, it will overfit. So that's why this is very prone, very, very, very. So this was the total concept of decision tree. Now tell me one thing, do you want random forest right now? If yes, we'll continue. Before that, let me open the meeting, else I can't see. Do you want random forest right now? Raise your hand. See, right now I can teach. I am asking, do you guys need another algorithm that is random forest to be completed right now? Raise your hand if yes, else no. Okay, put a thumbs down to no, put a thumbs up to yes. Why I am not teaching good? Hey, seriously, you guys understand? Did you guys understood all the concept? Too much stuff for one class. I want to tell you one thing, guys. Frankly, this whole stuff I learned within around 35 to 40 minutes. What I am teaching you. So this is not too much. If you go more mathematical intuitions of it now, 2 to 3 hours, bare minimum. Okay, fine, no issues, guys. See, from tomorrow or day after tomorrow, one class is getting over. Like one more batch is going on for the AI prompt engineering. So if that gets over, we can have 2 machine learning classes in a day, right? So get ready for that torture. Okay. So yes. Okay. Anything else you want to ask? You want to tell? Any doubt? See, I want to tell one thing, if you are interested, those who are watching on YouTube, if you watched before this week, fine, else no issues. There is one group, DSA, like courses going on by HCF, DSA. Right. In that, randomly, me and two more guys were discussing like a random talk we are having. So we decided to donate something to really needy people, needy children actually, needy children. The point was कि 64, I think so, 64 samosas or five munch. But then I thought this is not sufficient. Like last time I did, but last to last time, I think so, yes, 1 year back I did. Again I am doing, but for different college, different school. Ki we are gonna organize the HCF, gonna organize 1 day session. We are having a talk with UMS, upper middle school, that have from 10, like first class to 12th class, government UMS of Bihar. School name I won't reveal right now because it is not covered. Like completed, the deal is not yet completed, but mostly yes, they are like too happy. So 1 day session on two topics. First, career guidance. Another topic, AI, how they can go in AI field. Like mostly for this class will be from student of class 8 to 12. Right. We'll try if like teachers knows better, no, okay, which students are capable of this. So if in case they are giving us from 10 to 12, fine. So the point is that on that day only this thing will be done, 64 samosa, whatever we want to give. So I think so this is more important, that career guidance is the most important thing. If they got it right, their career will be streamlined and proper. So this is what we have thought of. If you want to do anything, like if you have any kind of idea or something, okay, bro, you can do this also, this is what I want, I do the similar thing, something, whatever you have, you can directly message me or kya, nothing. Put in a comment, or you can directly message me if you are HCF member or intern. Directly message me, you 100% have my number. So this is the thing. So if you have any idea, if you want to share, you can share it right now also. You can text me also. Okay. If you are nearly available to Bihar, you can come also. I'll give you the place to stay and all, everything. 2 time meal I'll also give. Okay. Not more than that. So if you want to come, you can come. Jokes apart. So this is the thing which we will do within a week. Okay. So that's what I wanted to tell you. If you have doubt, anything you want to ask, you can ask, else you can leave. Today class is over. Tomorrow we'll cover random forest. If you have doubt, you can stay and ask, else you can leave. Yeah, brother. Just a second, I'll stop video recording.